So we'll start with next unit, facts, that is flexible AC transmission system. In first unit, we have covered general information regarding semiconductor devices used in power system, its rating and power transfer capability. So in this unit, we are going to study what are types of fax controller that are used to control the power transfer in AC system. So before starting with the fax controller directly, we'll have some introduction. The power flow in transmission line are influenced by faults caused by lightning discharge and decrease in insulation clearance, variation in loads, variation caused by weather and other factors, generation pattern in deregulated environment, and also tends to vary contingency. So these are some factors which affects the power flow in transmission system, and our system should be such a way that it can compensate these problems. So we need to control or we need to have control over the power transfer which can be done using fax controller. Effects due to overloading of lines, system security, stability resulting outages, tripping of protective relays, voltage collapse are also the effects that directly comes in line with power transfer capability. That means whatever the faults occurring on the transmission line directly affects the power transfer capability. So our system should be such a way that it should clear the fault as early as possible. So FACTS is alternating current transmission system incorporating power electronic based and other static controller to enhance controllability and increase power transfer capability. Or we can have another definition as an electronic based system and other static equipment that provides control of one or more AC transmission parameters or transition parameters. So the fax controller or fax is a system that controls the power in the system by controlling different parameters that can be. So fax system can control the power transfer capability by controlling various parameters such as voltage, current, power angle, etc. And this fact is nothing but a semiconductor devices. So we can say that it is an electronic based system which can be connected either in series or parallel. When it is connected in series, it controls the voltage. When it is connected in parallel, it controls the current. Or we can connect simultaneously in series and parallel according to our system requirements. Classifications of facts are series controller, shunt controller, combined series controller, and combined shunt series controller. Depending upon power electronics used in controller, variable impedance type, and voltage source converter. We are familiar with second type, that is voltage source converters, which we have covered in UG, and are nothing but static synchronous compensators or SVCs, STATCOM, DISTATCOM, UPFC, IPFC, etc. Variable impedance type controllers are static war compensators, thyristor controller, series capacitor or compensator, TCSC, thyristor control phase shifting transformer TCPST. VSC based fast controller are static synchronous compensators, static synchronous series compensators, in interline power flow controllers IPFC, and unified power flow controller UPFC. Advantages of fast controllers over variable impedance types are: it is compact in size, technically superior because we can have entire control over this device, can supply require reactive control current or voltage even at low values of bus voltage, can be designed to have inbuilt short-term overloading capability, can supply active power if it has energy source or large energy storage, requires self-commutative power semiconductor device IGBT, GTOs or MOSFET. Self-commutating is nothing but it can turn off automatically. It we can have control over its switching, that is turn on and turn off capability. So we'll start with basic rough ideas regarding series controller. This part will be covered in next slides in details. Today we'll just have introduction over it. Series controllers. It injects voltage in series with the line through injection transformers. It serves as variable impedance such as capacitor, reactor, power electronic bus variable source of main frequency, subsynchronous and harmonic frequencies. As long as voltage is in phase quadrature with line current, it supplies or consumes variable reactive power. When voltage and line current, series controller mainly controls the voltage. So line current will remain constant. That means if you control a voltage in such a way that it is in phase with the line current, then the series controller only controls reactive power. But when voltage and current are out of phase, it can also controls the real power, that is active power. Shunt controller injects current into the system at PCC, that is point of common coupling. It serves as variable impedance, variable source. As long as injected current is in phase with the line voltage, it supplies or consumes reactive power. That means when the injected current is in phase with voltage, it controls the reactive power. But when current and voltage are out of phase, it can also controls the active power. Next type of controller are combined series controller. Combination of separate series controller can be connected in coordinated manner in multi-line transmission system. One of the example is IPFC. The real power transfer capability IPFC makes it possible to balance both real and reactive power flow in the lines, thereby maximizing utilization of transmission system. Combined series shunt controller. The combination of separate series and shunt controller connected in coordinated manner in multi-line transmission system, one of the example is UPFC, injects current into the system with shunt part of the controller and the voltage in series with the line with series part of the controller. There can be real power flow exchange between series and shunt controller via power link. So we can control this combined series controller, series shunt controller in two ways. First method is via coordinated manner and second by connecting power link. So in coordinated manner we can have separate control. That means if I consider series controller, there will be one series controller in one transmission line and second series controller in another line. So they will be controlled separately for that particular line. But if I want to have control between these two controller, that is the one which is connected in upper line and below line, I want to control both the controllers at a time, I can use power link. So by using the power link, we can have the powerful exchange between the series controllers which are connected in both the transmission line, as well as series and shunt connected controller in the both transmission lines. So by using power link, we can have control between the controller itself.